of matter. So solids, liquids, and gases primarily. All right, and here are our objectives. Pause the video if you really want to peruse them. Okay, so what are the states of matter? So we have solid, liquid, gas, plasma. Plasma only on the stars, aka the sun. I love the little GIF, so I'm giving you some time to appreciate that. You can see the particles are arranged differently in the 3 states of matter that we're going to focus on that we're able to actually look at and study: solid, liquid, and gas. Okay, you can see gas particles far apart, liquid much closer together, solid the closest together, and we're going to talk about those differentiating characteristics as we continue. So solids. Solids, definite shape or fixed shape. Definite, fixed volume. The attractions between those particles are strong. The particles are close together and neatly arranged. You can see that in the GIF that is playing right now. And also what you can see is the motion of the particles. So the particles are in fact in motion, but because those particles are so close together, they're just vibrating. Okay, so the particles in a solid are in motion. They're just vibrating. All right, so let's look at liquids. Liquids, the shape is indefinite, meaning not fixed, not definite. The volume, on the other hand, is definite or fixed. The attraction between the particles is moderate. Belle says hi. The particles are close together, but they're not as neatly arranged. So you can see that again in the GIF. What you can also see is the motion. The particles can slide past one another. Okay, so what does it mean, the difference between the shape and the volume? So volume, 10 milliliters is 10 milliliters is 10 milliliters. Doesn't matter if it's poured on the table, in a glass, or in a little tiny cup. The shape, though, is going to change based on the container. So the shape of those 10 milliliters poured on the counter is all spread out. The shape of the 10 milliliters in a big glass is just all hanging out on the bottom. In a small glass, it's going to fill it up a little bit more, okay? Now let's talk about gases. In gases, the shape is indefinite or not fixed, and so is the volume. The volume is also indefinite or not fixed. The attractions are very weak between the particles. The particles are far apart, which you can see in the GIF, but also you can see the particles moving all around, and they're going to bump into each other and change direction. So 2 particles coming like this, and then they'll bounce back in the opposite direction. All right, so the particles in a gas are freely moving around. They will bump into each other and change directions. Okay, now a gas will expand. Those molecules will get further apart to fill its container. Okay, so whatever container it's in, it's going to fill, but also means that gases can be compressed and squished down. That space, they can be lessened. They can be forced closer together to fit the gas in a smaller container. That's what happens if someone has an oxygen tank to help them breathe. The oxygen gas was compressed to allow it to fit into a smaller space. Okay, so how do the states of matter change then? Okay, so plasma is included here, but we're not going to talk about it beyond this point because we're not going to be able to experiment or view that in lab itself. Okay, so plasma, is so much heat, so much energy has been added that the electrons are freely moving around. So that process in changing from a gas to a plasma is called ionization. But we are going to focus only on the transition between solids, liquids, and gases. So as you move from solid to liquid to gas, you're going to need to add energy, add heat, increase the temperature. Okay, and then to move from gas to liquid to solid, energy or heat is released and the temperature will go down. Okay, so each of those phase changes has a specific name, and we're going to focus on those. So sometimes we have to add energy. All right, so to go from a solid to a liquid to a gas, we have to add energy. Okay. And when we add energy, that is called endothermic. Endo, it's going in, endothermic. So that includes melting, which can also be called fusion, that's solid to liquid, evaporation, which can also be called vaporization, liquid to gas, and then sublimation, solid to gas. They love to ask that question on the chemistry exam, sublimation. And then sometimes energy is released, so the opposite, not absorbed, released. So those processes are called exothermic. That includes freezing, or also called solidification, that's liquid to solid. There's condensation, gas to liquid, and deposition, gas to solid. Okay, so think. Describe the physical and chemical changes that occur when a pot of water is boiled over a campfire. So think about it. The water's heating up. It's going to be changing from a liquid to a solid, right? But then you also have the wood burning. Okay, so a physical change would be the converting the liquid water to a vapor called evaporation or vaporization. But then a chemical change is the reaction between the wood and the oxygen that generates heat, and it forms carbon dioxide and ash in the process. So chemical because new substances are formed, physical because it's still H2O even though it's a gas. Which of these processes is an endothermic physical change? That means you have to add energy in to make it happen. Melting of butter. Melting is endothermic. Okay, which state of matter fills its container? That's a gas. Which state of matter has definite shape and volume? So both shape and volume are definite. That's a solid. Which state of matter has particles that slide past one another? That would be a liquid. Which state of matter has particles that are in motion? That's all of the above. Remember, even in a solid, they're vibrating. All right, in class, we'll be reviewing with a blue kit. Good times. But that's it. That's an introduction all about the states of matter, solids, liquids, gases, with a shout out mention to plasma. I hope you learned something new today.